Sumo Insight Global. The channel to encourage reading, awakening knowledge.
Healthy eating and exercise. The perfect combination for a fulfilling life.
Vitamin B1. The nerve spark. The B-complex family. The B-complex is not a single substance, but a family of essential water-soluble vitamins. Although they have different chemical structures, they share the same natural sources, such as liver and yeast. The story of this group began in 1911, when researcher Casimir Funk isolated a concentrate capable of curing beriberi. At the time, it was simply called vitamin B. However, scientists soon discovered that it contained a whole army of vital nutrients, including riboflavin, folic acid, and today's star, thiamine, also known as vitamin B1. Thiamine was the first member of the vitamin B complex to be chemically identified. The events that led to its isolation actually date back to the late 19th century, when Takaki dramatically reduced the incidence of beriberi in the Japanese Navy by implementing certain dietary modifications. Shortly after that, Eichmann, a Dutch physician in Java, demonstrated that people who developed beriberi while feeding primarily on polished rice could be cured of their disease by adding rice polishings to their diet. Furthermore, he reproduced these clinical observations experimentally in chickens. Sometime later, Funk isolated a crystalline substance from rice polishings and yeast that was effective in preventing and curing experimental beriberi. The compound contained basic nitrogen, which was believed to be an amine essential to life. Therefore, Funk named the substance vitamin, a term widely adopted to designate accessory food substances, and this designation was maintained even when subsequent research revealed the broad chemical spectrum of essential dietary substances. Following the demonstration of the multiple nature of vitamin B, the anti-beriberi factor was named vitamin B1. In 1926, vitamin B1 was isolated in crystalline form by Janssen and Donath, and in 1936, Williams determined its structural formula, which was confirmed by synthesis in the same year. The Council on Pharmacy and Chemistry adopted the name thiamine to designate crystalline vitamin B1, which is now the official name in the USP. Similarly, official names were given to the other components of the vitamin B complex following their chemical identification. Thiamine, the shield of the nervous system. Scientifically named thiamine, vitamin B1 is the true guardian of our nerve health. It acts as a vital cog in our body's machinery, transforming into thiamine pyrophosphate. This is the exact substance that allows oxygen and glucose to fuel our heart and nerve cells. As an anti-beriberi and anti-neuritic nutrient, it prevents our nervous system from short-circuiting. Once ingested, it travels straight to the hardest working organs: the liver, heart, brain, kidneys, and muscles. Without it, the body accumulates pyruvic acid in the blood, a clear sign that energy production has failed. The danger of deficiency and the threat of alcohol. A lack of thiamine is never silent. Historical research has shown that severe deficiency leads to beriberi, which manifests in two forms. Dry beriberi. It attacks the nerves, causing numbness, muscle weakness, and even paralysis. Wet beriberi. It targets the heart, causing swelling, a rapid heart rate, and heart failure. Moreover, the mind suffers from memory loss, mental fatigue, and irritability. A critical warning: alcohol is one of the greatest destroyers of B1. Many symptoms seen in chronic alcoholics, such as the mental confusion of Wernicke-Korsakoff syndrome, are actually signs of a profound thiamine deficiency. Technical properties and food preparation. For those managing their diet, pay close attention to two vital details. Heat-sensitive. Thermolabel B1 is sensitive to excessive heat. Prolonged cooking can destroy it. Water-soluble. It dissolves in water. If you boil vegetables rich in B1 and throw away the cooking water, you are pouring the vitamin down the drain. The daily requirement for a healthy adult ranges between 1.8 and 2.3 milligrams, mg. It might seem like a small amount, but its concentration in food is measured in micrograms, mcg. Where to find it? The potency ranking, per 100 g. To secure your daily intake, here are the ultimate sources. Food source. Concentration, mcg. Brewer's yeast powder. 14,050, the absolute king. Peanuts, with skin. 5,200. Barley germ, 4,200. Rye germ, 2,200. Rice bran, 1,400. Brazil nut, 1,094. Fresh soybeans, 900. Note: brown rice contains 320 micrograms, while polished white rice loses almost all of its nutrients during processing. Integrating these foods, especially cereal brands and germs, ensures that the engine of your nervous system runs without a hitch. Since the body does not store thiamine for long, your supply must be daily. Take care of your vital spark. The engine of cellular oxidation, the tireless component, riboflavin, vitamin B2. History and discovery. Riboflavin was first identified in milk by Blythe in 1879. At that time, the substance was called lactochrome due to its source and its intense yellow color. Its physiological significance was not immediately evaluated. Later, equally pigmented compounds were isolated from various sources and named flavins, prefixed with the names of their origins, e.g., lacto-ovo-hepatoflavin. It was soon demonstrated that these diverse flavins were identical in chemical composition. In the meantime, water-soluble vitamin B was separated into two factors. B1, a heat-labile anti-beriberi factor. B2, a heat-stable growth-promoting factor. The doubt regarding the identity of vitamin B2 ended when lactoflavin was synthesized, revealing its characteristic yellow color and full biological activity. It was named riboflavin due to the presence of ribose in its structure. Chemistry and function. Riboflavin acts in the body in the form of two fundamental coenzymes, FMN, flavin mononucleotide, and FAD, flavin adenine dinucleotide. Both play a vital role as coenzymes for an extensive variety of respiratory enzymes in cellular metabolism. Unlike its sister B1, vitamin B2, or riboflavin, is a heat-stable component. This means it resists heat better during food preparation. It is indispensable for your body's functions to occur normally, acting as a key player in cellular oxidations, the process by which your cells breathe and generate energy. In addition to promoting growth, it is vital for blood regeneration, proper heart function, liver health, protection of your ocular system. Warning signs. Deficiency. A lack of riboflavin does not go unnoticed. In severe cases, deficiency can lead to paralysis and nerve degeneration, but the visible symptoms in daily life are what should draw our attention most. B2 deficiency manifests in three main ways. On the skin, oily peeling, seborrheic, on the sides of the nose and ears. In the mouth, the appearance of cracks in the corners of the lips, called chylosis, and an inflamed tongue with a purplish-red color. In the eyes, constant tearing, itching, light sensitivity, photophobia, corneal vascularization, and even the early development of cataracts. Note: deficiency may also be associated with normochromic anemia. Daily needs and power sources. To keep your health in check, an adult needs 2,200 to 3,000 micrograms mcg of riboflavin daily. The riboflavin ranking, per 100 grams. Food item. Concentration, mcg. Brewer's yeast powder, 4,612 micrograms. Fresh dates, 1,750 micrograms. Red peanuts, skin, 1,570 micrograms. Broccoli, dehydrated leaves, 1,020 micrograms. Hazelnuts, 675 micrograms. Cow's milk, whole, 653 micrograms. Walnuts/egg yolk, 555 to 575 micrograms. Green vegetables, mustard, spinach, parsley, 250 to 375 micrograms. Fruits like pineapple, banana, cashew, and mango also contribute, though in smaller proportions. The secret lies in variety. Riboflavin is the pigment of life that keeps your cells young and active. Don't let your engine stop for lack of quality fuel. Take care of your internal chemistry. But our journey through the B complex is just beginning. In our next video, we are going to unlock two more giants of metabolic knowledge: nicotinic acid and pyridoxine. You will discover why one of these vitamins caused one of the greatest epidemics of dementia and skin sores in human history, the terrible pellagra, and how the other acts as the true maestro behind the production of our happiness and well-being neurotransmitters. What happens when these two gears fail in your brain? That is what you will find out in the next chapter. Turn on the notification bell so you don't miss it. I'll see you in our next awakening to knowledge. Until then.